In question number 2, we're still doing limits, but we want to find the limit from the functional expression. In problem 2, part A, we want to find the limit as x approaches 5 of x cubed minus 3. This is one of these functions where we can actually evaluate the limit via direct substitution. Everywhere I see the x, I can replace it with the number 5. And the reason for this is because the function x cubed minus 3 is continuous at x equals to 5. So we can plug the 5 in. We get 5 cubed minus 3, which is going to be 125 minus 3, which should be equal to 122. So the limit in part A is going to be 122. In part B, you could try the same thing. If you plug 3 into this expression, this rational function, what you would get, however, is going to be 0 over 0, which is what we called indeterminate. There may be a limit, there might not be a limit, but we're not going to be able to find it out via direct substitution. One of the ways that we found to kind of work on problems of this form is if you can algebraically simplify the function, it may be possible to plug in the value into the simplified version of it. And we can certainly do that with this one. If we look at the numerator factors as t minus 3 times t plus 3, all divided by t minus 3. We see that both numerator and denominator have a common factor of t minus 3, which we can go ahead and cancel out. So this is equivalent to the limit as t approaches 3 of t plus 3. And now we can find the limit by direct substitution. The limit is going to be 3 plus 3, which is going to be equal to 6. In part C, we want to find the limit as x approaches 0 from the right of x minus 1 over x. For this limit, if you tried to plug in a 0, what you would get would be something like this, which is going to be 0 minus 1 over 0. 0 itself is 0, but then we kind of end up with this expression, a negative 1 over 0. We saw in class this is different than an indeterminate form. So the indeterminate forms were 0 over 0. Here what you have is a non-zero number on top of 0, which means that this limit is going to go towards some type of infinity, either a positive infinity or a negative infinity. To determine which one it's going to be, let's pick an x value that's kind of close to 0 from the right-hand side, and let's look at the sign of that value. So a number that's relatively close to 0 on the right-hand side here would be an x value of, let's say, maybe 0.01. If I plug 0.01 into that expression, I would have 0.01 minus 1 divided by 0.01, which would give me the value negative 99.9. We already would know from above that the limit's going to be either positive infinity or negative infinity, and by plugging in a value that's close to 0 on the right, seeing a output like negative 99.99 would indicate to us that the proper limit is going to be negative infinity.